Hello, today we're going to talk about selection sort. First of all, what is selection sort? Selection sort is an algorithm that sorts a list by comparing all elements to find the smallest or largest number in the list. Selection sort, there are two parts of the list: sorted and unsorted. The selection sort puts elements into the sorted list until there are no more unsorted elements, which means that the whole new list will be completely sorted. It compares the first element in the unsorted list with all the elements, and when it finds the element it is looking for, it will exchange spots with the element in the first position. So in the first position, you'll have a number, and then it searches through the whole list to find a smaller number. And if it finds a smaller number, then it will replace it with the first element in the unsorted list. Consider this array example with index numbers 0, 1, 2, 3, 4 and numbers 5, 8, 1, 9, 2. Now 5 is set to our current minimum value, and we have to search through the whole list to see if there is another number that may be smaller than it. Now we compare that to 8, and 5 is still the smallest number, so we keep it as our minimum value. We compare 5 to 1. 1 is smaller than 5, so that means that 1 is our new minimum value. Then we do the same for 9, and we do the same for 2. And since neither of those are smaller than 1, 1 is our minimum value in this whole array, which means we need to put that in our first position. So we swap the index numbers, and we'll have this new array. And that means that there is one element that is sorted, and 4 elements in this array that are unsorted. We must compare 8 with all the other numbers, so we set 8 to our minimum value, and we compare it to 5, which is our new minimum value. We compare 5 to 9, and 9 is greater than 5, so 5 is kept as our minimum value so far. And then now we compare it to 2. 2 is smaller than 5, so we must consider that 2 is our new smallest number. And once we have done that, we have to swap positions with the first element in the unsorted list so that it is where it needs to be. So we set 4 index and we swap it with 1. And then we'll get this. Now 5, even though it's in its correct position already, we still have to check through the whole list to see if it is where it's supposed to be. So 5 compares to 9, and 5 compares to 8, and 5 is our smallest number, so it stays where it is. Now, 9 is our current minimum value, and we won't need to check the next one because that will obviously have to be our highest value. So we compare 9 to 8, and since 9 is greater than 8, 8 is our minimum value, and we have to swap those positions until we get this final array. Here's an example Java code with int I and j for variables to use in our for loops, and n as the number of elements in the array. So in the first for loop, it checks through every single element in the array to see if it's in its correct position. So first it sets the minimum value to j, which is 0. So the first number in the unsorted list. And the second for loop inside will be checking if it is smaller than the other elements in the array. So you have the new element. If it is less than the current minimum value, which was the value that you had in the first position, then it will change it to the new minimum value. And to swap them, we have to say if minimum is not equal to j, which is our current value of the first position, then you'll need to swap them. And it repeats this over and over and over again until you'll have the completely sorted list and everything in its correct position. A real-life application. Selection sort isn't very useful for big and large lists because its runtime is not very good. It has a ON squared runtime, and for that reason it can't run large lists. But you could use it to sort through lists to sort ages, or from youngest to smallest, or youngest to eldest, or eldest to youngest, because it's not very complicated and it could be very short. So that's all for the real life application. Now the ON squared runtime is actually the runtime for its best case, worst case, and average case scenario. So the whole runtime is just ON squared for all cases, because it's a for loop inside a for loop, and you'll have n minus 1 multiplied by n, which will get you n squared minus n, and then that will just be ON squared as the big O notation because you take the largest value. Now, that is all for this video, and hope you guys learned something about selection sort.